Dear students, for today we'll see what do we mean by instrumentation amplifier, which comes under the subject of analog electronic circuits in the topic active filters. So let's go with the topic, which is instrumentation amplifier. Now, first, why do we require this amplifier? Now, this amplifier is going to amplify the input at the output with a good signal strength. But why do we require? Now, this is an amplifier which is used in many processing systems. Every physical parameter, whatever it is, like temperature, resistance, vibration, okay, anything you can take. You can take temperature, you can take your speed, you can take vibration, okay, you can take humidity, okay, anything, whenever you convert that with the help of a transducer, with the help of a transducer into an electrical quantity, the output, whatever it is, voltage or current, will be low in magnitude, and it will be interfered with many noise and other type of interferences. So to amplify only the signal, to amplify only the information data out of that at the output of transducer, and to eliminate all the noise, whatever it is about, or all the interferences which is going to disturb the information. If you are having that process done, that process can be done by an amplifier, which is called as instrumentation amplifier. So first we'll see what do we mean by instrumentation amplifier. So what is an instrumentation amplifier? An instrumentation amplifier is used to amplify very low level signals, rejecting noise and interference signals. And it can be useful in measuring many applications like heartbeats, blood pressure, temperature, earthquakes, and so on. So in such cases, the output will be very low in magnitude. That output has to be amplified. And along with amplification of the main information, you have to also eliminate or reject the noise and interference signals. So it is a very precise amplifier. Then what are the features what an instrumentation amplifier should have? Now here we have given around 5 important features. So the first one is inputs to the instrumentation amplifier will have very low energy signal, because those are the output from the transducer, and transducer is a device which is converting your physical parameters like temperature, pressure into electrical energy. Therefore, the instrumentation amplifier should have very high gain. So gain of the amplifier should be very high and should be accurate. Accurate means it should amplify only the signal which is important, not the noise. Second one, the gain should be easily adjustable using a single control. So when we see the circuit diagram, we will see that there is a single resistance by which you can adjust the complete gain of the amplifier. Number 3, it must have high input impedance and low output impedance to prevent loading. Number 4, the instrumentation amplifier should have high common mode rejection ratio, CMRR, so that noise and other interferences can be rejected. Number 5, it must also have high slew rate to handle sharp rise times of events and provide a maximum undistorted output voltage swing. So these are some of the features what an instrumentation amplifier should have. Now let's go to see the instrumentation amplifier circuit. So here if you see, this is the circuit of instrumentation amplifier. So it is having an input here which is called as V1, and it is given to a non-inverting amplifier. This is a non-inverting amplifier. Okay, amplifier. This will be a non-inverting amplifier number 1. Similarly, you have one more input here, V2. Okay, and here you are having one more non-inverting amplifier. This is also a non-inverting amplifier number 2. Okay, So these are the two non-inverting amplifiers which form the input stage of your instrumentation amplifier. So in the input stage, we are having two inputs, V1 and V2. V1 is given to the non-inverting amplifier 1 and V2 is given to the non-inverting amplifier 2. And here you can see you are having R1, R1R or resistance of both circuit, and because of that you can have here something called as R gain resistance. Now this is one which if you adjust, you can adjust the gain of the circuit. Okay, now here the output of the first non-inverting amplifier and the output of the second non-inverting amplifier are given to the two inputs of the third amplifier, which is acting as a difference amplifier. This is your third amplifier which is acting as difference amplifier. So this is differential amplifier. So output of this will be the difference in an amplified version of its two inputs. So here the output V naught will be amplified. Now this is the amplification factor. This will be the gain of the complete circuit multiplied by difference of the two inputs V2 minus V1. V2 minus V1. So this will give you an amplified version of the difference of the two inputs at the output. So instrumentation amplifier is one which is overall a differential amplifier. The input stages are two non-inverting amplifiers. The gain of this whole circuit can be adjusted by the R gain resistor. Only one gain resistor you can handle the gain of the full circuit. And the output of the last third amplifier, which is a differential amplifier, will be amplified version of the difference between the two inputs V2 minus V1. Okay, now this is how you are going to amplify the signal, the data in the output of the transducer. The signal will be amplified, and this is how your noise and other interferences can be rejected, because this circuit will be having a very high CMRR, common mode rejection ratio. Then we'll go to see the advantages of instrumentation amplifier. The gain of a 3 op-amp instrumentation amplifier can be easily varied by adjusting the value of one resistor R gain that we have already seen. R gain was in between the first and second non-inverting amplifiers. Second is the gain of the amplifier depends only on the external resistors used. That is also true. Third is the input impedance is very high due to the emitter follower circuits of amplifier 1 and 2. So the input impedance is very high, which is good for the loading effect. Fourth one, the output impedance of the instrumentation amplifier is very low due to the difference amplifier 3. So output impedance is low. So the input impedance is high and the output impedance is low. So that will see that the loading effect is not affecting much to the performance of the instrumentation amplifier. Number 5, the CMRR of the op-amp 3 is very high and almost all the common mode signals will be rejected, and in the process you can reject the noise and other interference signals. Then what are the applications of instrumentation amplifier? There are a few applications. So the first applications can be a data acquisitions from small output transducers like thermocouples, strain gauges, measurements of Wheatstone bridge, etc., whose outputs will be very small in magnitude, and those outputs has to be amplified, and they can be amplified by using instrumentation amplifier. Number 2, these amplifiers are used in navigation, medical applications, radar, etc. Number 3, these amplifiers are used to enhance the signal to noise ratio in audio applications like audio signals with low amplitude. These amplifiers are used for imaging as well as video data acquisition in the conditioning of high speed signal. And number 5, these amplifiers are used in RF cable systems for amplification of the high frequency signal. So these were a few applications which we have mentioned. There are many applications of instrumentation amplifier. These were around a few applications. Okay. Thank you, students.